shuttle external tanks. A second tool has been installed to perform vertical welds on the fuel tank barrels. Along with the robotic weld tool, this machine allows upper stage engineers to test all the fabrication processes for the vehicle before assembly of flight hardware begins. Flight hardware will be created at NASA's Michoud assembly facility, and delivery of their friction stir weld tools has already begun. The upper stage is also responsible for providing Ares 1 with roll control, keeping the vehicle stable and properly aligned during flight. Manufacturing and testing of a variety of roll control subcomponents is now underway. Valves to control everything from hydrazine fuel to helium are being built, along with the necessary electronics to drive the system automatically or by crew input. Ares engineers have also tested a small solid rocket for use as an ullage settling motor. This motor will be used to settle any fuel in the upper stage tanks when the spacecraft is in orbit. Further tests are planned in the series to help finalize the ullage motor's design. In addition to hardware manufacturing and testing, the upper stage team has already begun considering the practical issues of ground operations in their design. Using computer models alongside a full-scale mock-up of the vehicle's instrument unit and interstage, the team continues to optimize subsystem placement by involving the ground crew and manufacturing experts in the ongoing design process. The Ares 1 upper stage will be powered by the J2X engine. This engine, an evolved version of the J2 that propelled the upper stages of the Apollo-era Saturn 1B and Saturn V rockets, burns liquid oxygen and liquid hydrogen for fuel. The engine will measure about 15.5 feet long and 10 feet in diameter at the end of the nozzle, and will weigh over 5,000 pounds. Between February and April of 2007, Marshall engineers conducted 14 hot fire tests on a variety of subscale injectors for the J2X. These injectors channel liquid hydrogen and liquid oxygen into the engine's main combustion chamber. Another test series examined the design for the J2X gas generator system. Developmental hardware components were fabricated for a workhorse gas generator, designed to withstand longer test operations than would be required for flight. The workhorse gas generator engineers ran 53 individual tests in a variety of injector configurations. Engineers have also gathered data on the Heritage J2 liquid oxygen inducer and loads placed on the engine nozzle in subscale testing facilities. The culmination of these earlier test activities was the J2X Power Pack 1A test series. Modifying a test stand at Stennis Space Center handed over by the Space Shuttle program, Ares engineers conducted an extensive series of tests using J2 Heritage hardware. Testing with this power pack allowed engineers to explore the limits of the engine design and provided test personnel with valuable operation experience for future full-scale testing. A total of 6 hot fire tests were conducted between February and May of 2008, amassing more than 1,300 seconds of operating time at power levels up to an equivalent of 274,000 pounds of thrust to inform the design process and support the Ares 1 mission. Once the power pack was removed from the test stand, the components were disassembled and examined by engineers at Pratt & Whitney Rocketdyne to determine what effects the test sequence had on the parts. More power pack testing will be conducted in 2010 using developmental J2X turbo machinery that is being fabricated now. In spring of 2007, Ares also began construction of the largest engine test facility built by NASA in more than 30 years. The new stand, designated Test Stand A3, will be used to test fire the J2X engine at simulated high-altitude conditions. Test Stand A3 is scheduled to be completed in 2010. The J2X team passed a major milestone in November 2008 with the successful completion of the engine's critical design review. This makes the J2X engine the first operational component of the entire Constellation program to progress beyond critical design review. In 2009, Ares will take a major step towards operational capability with the launch of the Ares 1X flight test vehicle. The Ares 1X will use existing space shuttle hardware for the vehicle's first stage and simulated hardware to approximate the mass and aerodynamic characteristics of the upper stage and Orion. This test flight will provide engineers with data about the environmental conditions during an actual flight of full-scale hardware. In addition, the test will establish handling characteristics for the Ares design and verify that the vehicle steering and roll control systems operate as needed. It will also provide valuable information regarding stage separation and the recovery approach for the first stage. Finally, the Ares 1X flight will test new ground operations and launch procedures that will be used for Ares 1 at Kennedy Space Center. The roll control system for the Ares 1X will use existing hardware from decommissioned Peacekeeper ballistic missiles. Hot fire tests have been conducted to verify that these engines can fire in the short, pulsed mode necessary for use as a roll control system. The Ares team has also been conducting assembly and handling tests for the Ares 1X roll control system. A cold flow testing unit will be used to verify that the system will function properly during liftoff, while flight units are in the final stages of assembly for delivery to Kennedy in December 2008. Ares 1X will also supply engineers with important data regarding the avionics and thrust vector control systems on Ares 1. The team has previously tested the avionics in the Ares 1X Systems Integration Laboratory. Right now, final flight hardware for the Ares 1X test vehicle is being delivered and prepared for stacking at Kennedy Space Center. Upper stage mass simulator components from Glenn Research Center, as well as new forward structures and the first stage aft skirt, are already fabricated and awaiting assembly for the test flight. As preparations ramp up for the first test flight of the Ares 1, the Ares 5 cargo launch vehicle design team continue to make progress towards its initial test flights later next decade. Much of the work being done on the Ares 1 will be applicable to the Ares 5 design. The solid rocket boosters of the Ares 5 will use a 5.5 segment derivative of the 5-segment solid rocket motor developed for the Ares 1 first stage, and the Earth departure stage of the Ares 5 will be powered by the same J2X engine in use on the Ares 1 upper stage. Efforts are also being made to use common components, cabling, and other hardware to reduce development time and cost between the two vehicles. Studies and workshops are also being conducted to determine how best to utilize the Ares 5. In addition to its critical role in any lunar mission, the Ares 5's enormous cargo capacity, more than 400,000 pounds to low Earth orbit, will enable the launch of a wide variety of scientific payloads, from satellites to space-based telescopes. Wind tunnel testing is already underway on the Ares 5, providing engineers with data on the aerodynamic environments that will affect the vehicle during flight. In the coming year, Ares will continue to make great strides towards its first operational flight. Activities will include testing of the first stage's 5-segment demonstration motor, manufacturing of the first J2X development engine, a 3-parachute cluster drop test, creation of upper stage manufacturing demonstration article, and the launch of Ares 1X. The Ares projects are a nationwide effort, drawing on the talent of more than 3,700 personnel from across all of NASA and the American aerospace industry. Remarkable progress has been made so far over the project's short 3-year life, pushing the Ares 1 well beyond the concept stage. With hardware at every stage of development, from formulation to design to fabrication and testing, challenges have been identified and solutions are in work now. By incorporating NASA's rich heritage of space transportation systems into new Ares designs, the team continues to move forward on an ambitious schedule to firmly establish the United States as the premier spacefaring nation in the world.